Here are some nomenclature problems for you to try. Remember to pause when you come to the question, try the problem, and then resume it in order to check your answers. In doing these problems, remember to find your longest chain, draw a line through it, circle your substituents, number them, and name them. Go ahead and pause and try these problems and resume to check your answer.
To do this one, you can see the longest chain is pent, so we call it pentane. The substituents that are attached are two methyl groups because there's carbon in them, so I'm going to call this dimethylpentane. Now I need to number it, and from either end of the chain get 3, 3. Notice I put down two different 3s because each methyl has to have a number. If they were on different carbons, of course you'd have different numbers, but when they're on the same carbon, you still have to give a number to each substituent. To name this compound, I look for the longest chain. The longest chain must start with the CH3 and end with the CH3. So you can see that we have to include more than just what's written in a line. We've got to be a little more flexible and be able to look for the longest chain regardless of how it bends or might kink. Now you could either use the two carbons that are on top or the two carbons that are on bottom. You would get the same name either way, but you have to find the longest chain. Don't limit yourself with what is written in a row. Look to see, does it bend or does it kink, and go from for the very possible longest chain that you see in the molecule. Now if I look at this, I've circled the substituents here. By circling the substituents, it makes it so you can see them. I would draw a line through the longest chain, so I wouldn't count those again, but I had to highlight it in blue. And now you can see that the substituents are what's separate from that longest chain. So I'm going to name the longest chain hexane because there are 6 carbons in the longest chain, and now I'm going to put on my substituents. My substituent is an ethyl and a methyl. I put the ethyl first because the ethyl, it comes before methyl in the alphabet. Now I number. There are 2 ways I could number. I could number from the left, which gives me 1, 2 for the methyl, or I could number from the right, which would give me 1, 2, 3 for the ethyl. 2 is lower than 3, so we choose 2 for the methyl and 4 for the ethyl. Now look at these names and go ahead and draw structures for the names that are written here. Stop the video and write your structures, then check your answer after writing structures. This first one, we would draw the longest chain of hex. So I'm going to put 6 carbons in. And when you first draw it out, you might want to just put carbons all attached 6 in a row without any hydrogens. Many people find it works well to put just the carbons down and then attach hydrogens to make sure each carbon has 4. So if I look at this, there are 6. That gives me hex. But the methyl and the ethyl have to be attached. So I put on the, I'm going to put a methyl group. And on the number 3 carbon, I'm going to put an ethyl group. Notice on the ethyl group that I have the carbon with only 2 hydrogens attached to the chain. Because if I had it the other way, so that the CH2 was written on the left and the CH3 was attached to the carbon on the left would have only 3 bonds to it, and the carbon on the right would have 5 bonds to it. You've got to always be careful with that kind of thing. And then I ask you this question, why is this not 3-isopropyl hexane? When this is written down, some students will look at that as being the longest chain and say it's hexane, and then want to name what's attached as isopropyl or as a propyl substituent. We call it isopropyl when it's attached in the middle of a 3-carbon chain. And the reason that we do that is our rule is we always choose a chain that gives us the most number of substituents. When we have the most number of substituents, the substituents are simpler, and we prefer to name that way. So that's why. If we look at drawing this molecule with the shorthand, which that's what you may have done, and that's fine. Unless in a problem I state use the condensed formula or use the shorthand, you can choose whichever way you want. If you use the shorthand, you would have written a 6-carbon chain, which is what I have written there. Then you would have attached a methyl on the carbon, and then you would have attached an ethyl, 3-carbon. And some of you may be saying, well, which end do I start my numbering? In the top molecule, you started your numbering, the number 1 carbon is on the right, and on the bottom one, the number 1 carbon is on the left. Which do I do? Well, you don't have to worry. You can choose either. Organic chemistry is incredibly flexible, and that flexibility makes it very frustrating for students because they want to have things really rigidly done. But these molecules are floppy, and we realize that, so we flip-flop them around a lot. And it's going to take a little getting used to for some of you. If I look at this molecule, decane means 10 carbons. So I've put 10 carbons in a row here. Okay, now it says ethyl and dimethyl. So I'm going to put in my ethyl first. What did I do wrong here? Do you see what I did wrong? And you see students doing this a lot because they forget about counting the number of bonds on the carbon. If you look at the way that I've written my ethyl group on here, you can see that the carbon in the ethyl that is attached to the 10-carbon chain has 3 hydrogens plus 2 bonds to 2 carbons. That gives it 5 bonds, which is a no-no. If you look at the carbon on the right, you can see that it has 1 carbon bond and only 2 hydrogens attached to it, which gives it 3 bonds, which again is a no-no. You don't want to do this. You write it like this, where the CH2 is the one that is attached to the chain, so be careful about that. Okay, next we're going to put in the methyl group. It is 2,5-dimethyl, so I've gone and found the number 2 carbon and the number 5 carbon, and put in the 2 methyl groups. And now I need to put in the isopropyl. The isopropyl group is on the 3 carbon, and isopropyl is a propyl group in which you have the carbon in the middle attached. Notice, count the number of hydrogens on each carbon, and you'll see that each one has 4 bonds, which is the way it needs to be. Alright, again, I started my counting on the left and went to the right. I could have done this where I started my counting on the right and went to the left. If I did this with the skeletal or short method of drawing an organic molecule, I would first put in my 10 carbons to make the decane. Then I'm going to put in my ethyl on the number 7, and I'm putting in my 2 methyls on the 2 and the 5, and then my isopropyl group on my number 3 carbon. On this last structure, I have hexane, so I write 6 carbons in a row. Then I'm going to need on the number 3 carbon and the number 4 carbon a methyl. I check and make sure that all my carbons have the proper number of hydrogens, and then I'm through with this. To do this with the skeletal formula, I first draw in my 6 carbons for the hexane. Then on the number 3 carbon, I put in an ethyl, and on the number 4, I put in a methyl. Again, you see I'm counting from either end in the structure on the top. I counted from the left, and in the structure on the bottom, I counted from the right. It doesn't matter.